Here in this example, we are solving a rational equation. Step 1, recognize that it's a rational equation. Check. Step 2, factor all denominators. Check. Step 3, identify the least common denominator and then multiply the entire equation completely through by the least common denominator. Well, the least common denominator here would be x plus 1 times x plus 2. All right, now we're going to multiply the entire equation completely through by x plus 1 times x plus 2, but we're going to be efficient with resourceful about how we're showing our work and not get carried away showing too much stuff. So this over here, it's going to multiply over here, okay? X is still there. What crosses out? If you said x plus 2, you're a genius. Then after the x plus 2 crosses out, what's left behind? Well, that's just going to be x and x plus 1. So I'm going to get that ready right over here. X times x plus 1 plus the next fraction or rational expression, has a 1 in the numerator, so that really doesn't matter. What goes away, what stays behind? If you said that the x plus 1 crosses out and only x plus 2 is behind, you are correct. I didn't write the 1. I really didn't need to write those parentheses. And lastly, we're going to multiply it right over here. 5 times x plus 1 times x plus 2. What crosses out and what stays? If you said everything except the 5 crosses out, because that's all that stays, you're a genius. Now, next thing that we're going to do from here is expand and open everything up. Recognize that it's a polynomial equation now, and we're going to solve that. I did miss a step, but let's do that first. X squared plus x plus 2 equals 5. The step I missed, my restrictions. I know, I'm the worst, sorry. Restrictions are the values of x that would cause the denominator or multiple denominators in our original problem to equal 0, making expressions undefined. What numbers will be doing that for us? Hopefully we can all tell that x cannot equal -2 and x cannot equal -1. If it does, we run into a problem. So we're going to keep these on the side. If after we solve our polynomial, which has a domain of all real numbers, it's smooth, continuous, happy times, after we solve that, one of our solutions happens to be on our restriction list, we're going to acknowledge that that answer is what we call an extraneous solution. But let's keep it moving. Let's combine like terms. So I have x squared plus 2x, and I'm also going to get it equal to 0. So -3 equals 0. This over here, poorly written, I'm sorry, is a quadratic trinomial, and it looks like it might be factorable, right? So let's check that out. X squared must be x and x, no other option there. 3 is prime, so 3 and 1 is really all I have to work with at this time. I want a positive 2, so 1x and 3x. That means I need a positive 3x minus 1x. Lovely. If you double check it, foil it in your head. Please, I'm begging you to foil it in your head, especially when one side's plus and one side's minus. You guys do them backwards all the time. Why? I don't know. I don't think you're listening when I'm explaining it to you. Listen, please. Pretty please. So again, zero product property, we set each factor equal to 0. We get solutions of -3 and 1. Now, while these are solutions, we should double check. Are any of these numbers on the naughty list? They are not. So these work, and we have no extraneous solutions. Those are our 2 solutions. All right. So hope that you were able to crush it on this example. Hope that you feel like you are smarter every second. I hope that using these videos that you will start the example by yourself, press pause, and then only press play when you need to. And yeah, just keep doing your best. Okay. Have a great day. Oh, go to the playlist if you want to pick another one, or click the next video that pops up on the screen. Thumbs up if you got it, thumbs down if you hate it. Have a great night.